graph below shows the polar equation r of theta equals 2 cos 3 theta graphed on the interval AB. What are the values of A and B? All right, so obviously I don't have the whole picture. If you have your pictures memorized, you know that this is going to be, since that's odd, you're going to have a 3-petal, as I think a D, a 3-petal rose-looking thing that goes out to 2. And since this is cosine, it's, and I'm not even going to attempt to try to draw this, it's going to look like that. Oh, perfect picture. But that's not what I have. I have what appears to be like 1.5 petals, so I have to kind of deal with that. So what I'm going to do is I'm going to graph what 2 cos 3 theta looks like on a rectangular plane. All right. So if it's 2 and cos, it starts at 2, bottoms out at -2, no midline to worry about. This is just a regular 3 rows. It's going to go, let me get a different color. It's going to go down and up, down and up, down and up, and have 3 cycles completed, so at 2 pi. Now, how do I know that? The frequency is 3. So whenever you're given the frequency, that tells you how many times it's going to repeat once it hits 2 pi. If you're like, I don't like looking at that, I'd rather find the period, then fine. The period is going to be 2 pi over the frequency, and you can figure it out that way. So some magic numbers to look at, okay? It repeats every 2 pi, and it repeats 3 times. So halfway through at regular pi, we're at -2 here, okay? Halfway in between that, we hit the 0 axis, so that's pi over 2. And then we hit 0 here at 3 pi over 2. So, you know, just in case you need the numbers there, 0, pi over 2, 3 pi over 2. Nope, that's pi. Hee. It's my Michael Jackson impression. And this is 3 pi over 2 over here. Now, as you can see, at 0, we're supposed to start at 2. And you might be like, oh, hooray, that's what we have. At 0, we do start at 2. However, this is having us live in positive R land and approaching 0. So it actually starts out going like this. Okay. Now it hits 0, hits negative land, and hits 0 again. Okay. So like that. Now I know the picture's not really good at all, but what we know is now we need to be where we need to be. See, this part wasn't on the graph, but here we are at pi over 2, 0. So there's 0 at pi over 2, and at pi over 2, we're living in positive land. Sorry, I hit a button. We live at positive land and then come around. We are where we need to be. Okay. At somewhere here, we hit negative land and stop being negative. So as we go from pi over 2, we hit negative land and have a negative distance, which goes the opposite direction of what's going on over here. So what we have is a graph on pi over 2 to pi. I'm not even going to bother marking up the rest because clearly I can't draw any of this stuff. But tricky problem. Not a fan of it. Not a fan of it, which is funny because it kind of looks like a fan. But I personally am not a fan of it. But, you know, hope this helps.